Hi everyone, my name is Mehak. I am a student of VIT Vellore. Me and my teammate Pragya are going to present you a video in which we will talk about how to use a LDR or a light dependent resistor, which is called an LDR of course, to turn on and off another circuit or a LED. So this is basically our project, that is auto intensity control of street lights using Arduino. So wouldn't it be really cool if whenever a room gets dark, a light bulb automatically turns on and eliminates all the darkness? So in this very simple project, we will be focusing on eliminating darkness. We can even use the circuit for an emergency lighting system. Now first, let us talk about what is the need of this project. So as you know, street lights have become an essential part of our lives as they are a very important source of light, especially in the evenings and at night time also. So the main advantage of street lights is that they increase safety and they prevent accidents and collisions. So the objective behind this whole project is, if we compare this scenario with the previous times, like with the old days. So the street lights on the roads, in olden days, the street lights on the roads were controlled manually. But nowadays, streetlights are controlled automatically, or you can say by emerging automation technology. So by reducing the light intensity using LEDs, the energy can be conserved. Now we come to our main topic, that is auto intensity control of streetlights using Arduino. So what is this project is about? What does this term mean? So this term means that when the intensity of streetlight is automatic, that the intensity of streetlight is automatically controlled based on the sunlight conditions. So generally street lights are turned on during the evening time and they will continue to glow till morning. So this thing might result in unnecessary usage of power, as the lights will be glowing at full intensity at all the times. But using the auto intensity control of street lights using Arduino project, like using this project, we can control the intensity based on the ambient lighting conditions. So as an additional power saving feature, we are going to use LEDs for street lights because they consume less power, therefore less energy, less electricity, and so hence the overall cost will be reduced. Now regarding the installation of the Arduino IDE, I'm going to show you what instruction manual I followed while downloading and installing the Arduino software.
Yeah, so as you can see, this is the website from where I got the instruction manual to download the Arduino IDE software on Windows 10. So the instructions are, first we have to go to the software download page where we will get the link. So then we have to select the Arduino IDE installer with the extension .exe. Then we'll have to wait until the download process completes. After that, we'll install the software and we'll choose the components that we want to install as well as the install location. So here is the window where we will choose all the components to install, like the USB driver, the create start menu shortcut, the create desktop shortcut, etc. After all this, we will accept the driver installation when prompted by Windows 10. Now we have to select the zip package, and for that we should know that we need to install the both drivers manually. After all this, how we are going to download the Arduino drivers on Windows 10? Even for this, the instructions are mentioned. So first we have to go to Start, type Device Manager, and then double click the first result to launch the Device Manager. Then we have to go to ports. We have to locate the Arduino UNO port. In case you can't find that port, go to other devices and locate unknown device. Now select the Arduino UNO port, click on update driver, select the option browse my computer for driver software. Now go to the Arduino software download location, where we will select the arduino.inf file, arduino uno.inf, depending on whatever is your software version. After that, we will wait until Windows finishes the driver install process. So now that we've installed the Arduino software and driver on the computer, now it's time we will work on it. Now as you can see, I have installed my Arduino in C drive. So I will open the C drive. It's in program files. This folder is the Arduino folder where all the files are present. So for the programming purpose, to do the programming, I am going to open this file with the extension .exe. So when I open this file, this window comes. So this is the window where we can do our coding part, where we can write the program and all the instructions. Now we will move on to the hardware circuit design part. So this is basically the hardware circuit design part. So in this project, the components that we have used for the circuit are Arduino Uno, that is Arduino ACE. So there is an inbuilt ADC, analog to digital converter, which is present in the Arduino Uno with 10-bit resolution from 0 to 1023. As you can see, this is the Arduino Uno. Now the analog value from the LDR, this is the LDR, this one is the LDR. So the analog value from the LDR is converted to the digital values with the help of inbuilt. Now ADC in Arduino is to give values in range from 0 to 255 digital values. Now the most important component that we've used in this project is LDR. So as you can see, this is the LDR, this one is the LDR. So what is LDR? LDR is a light dependent resistor. It is a sensor which varies the resistance upon the falling of light. The resistance of LDR decreases with the increasing intensity of light and vice versa. So when light directly falls on the surface of LDR, its resistance decreases. The LDR gives analog output values and is connected to the analog pin on the Arduino. So this is the LDR, and through this wire it has been connected to the analog pin of Arduino. Now the output from the LDR is used to control the intensity of LED bulb. Now in this circuit, this is the LED bulb, the one in yellow. This is the LED bulb. Here we are going to use a 10 kilo ohm resistor along with the LDR to create a voltage divider circuit. So the resistor I'm talking about is this resistor, this one. This is the 10 kilo ohm resistor that we are going to use along with the LDR for creating a voltage divider circuit. Now the varying resistance of LDR is converted to a varying voltage that the analog pin of the Arduino would then be using in its logic. So along with these components, we will also be using a breadboard. This is the breadboard, as you can see, and a 10 kilo ohm resistor for creating the voltage divider that we've already talked about, and 1 kilo ohm resistor for the LED also. Now few breadboard friendly connecting wires and also a USB cable we will be using to upload the code to the Arduino. So along with all this, we will also be using a 16x2 LCD display and a potentiometer. So this is the LCD, this one is the LCD, and this one in blue is the potentiometer, as you can see, the one in blue. Okay, so now the question arises that why we have used Arduino in this project. So we're basically using this for analog to digital conversion of signals. Now what is happening is that we are connecting LDR with a resistor and forming the voltage divider circuit. Now with the properties of LDR, we are going to give the current to A0 pin of the Arduino, and according to the logic of our program, Arduino can sense the range of analog values from 0 to 1023. So it will scale down the amplitude of the current into the range of 0 to 1023, and then according to that range we will be setting up a threshold, which in this project is 200 units. Now if the current or the input signal value that we are getting from the LDR is less than the threshold value, which is 200, then the LED will switch on, else it will remain switched off. Now to make sure that signals are being sent properly, we are also using serial monitor, in which we will be displaying, it will be displayed whether the LED is on or off. This will also help us to debug the program, that is the project, in case even if our LED has been damaged or something like this happens. So we will come to know that at least in our output we are getting the correct response from the Arduino. Now as you can see here, this is the LDR and this is the resistor. They both are forming a voltage divider circuit. So one of the ends of the LDR is connected to the positive terminal and the another end is connected to the resistor. Look, the other end to the resistor and first end to the positive. This is the positive rail of the breadboard and this is the negative rail, and the other end is connected to the resistor. And this resistor is then connected to ground. So this is the resistor which is connected to ground. Now the signal that we are getting from connecting the LDR to the A0 pin of the Arduino. This is the Arduino. This is the A0 pin. This one. This one is the A0 pin of the Arduino. This is also called the analog read pin. So in Arduino we have different pins for different functionalities. We also have power pins. So this 5-volt power pin that I'm going to show you. So as you can see, there is a 5-volt power pin, right? And so this 5-volt power pin, we are using this pin to operate the voltage divider circuit, and we are also using the ground from Arduino. The signal pin that we can see here has been given to A0 pin, which is an analog pin, and only analog pins have the capability of reading analog values. So these are the digital pins. These are the digital pins. These pins, digital, is written digital over there, no? Since we are connecting it to analog pin, as you will see in the code, that we have set the threshold value to 200 units over here. Now actually before showing you the whole code, I will once again briefly list out all the implementation steps for the connections in the hardware. So we will start by connecting the 5-volt output of the Arduino to the positive rail of the breadboard. Then we will connect the ground to the negative rail of the breadboard. After that, we place the LDR on the breadboard and then attach the 10 kilo ohm resistor to one of the legs of the LDR. After this, we will connect the A0 pin of the LDR of the Arduino to the same column where the LDR and the resistor is connected, that is over here. Now we will connect the other end of the 10 kilo ohm resistor to the negative rail and then the second free leg of the LDR to the positive rail. So after making all the connections and uploading the code to Arduino, we will finally turn on the power supply of the project, which we are getting, that is the power we are getting from the USB, through the USB. Now we will move on to the program, that is the coding part. Now as you can see, we have set the threshold, this is the threshold value to 200, which means that if the signal that we are getting from the LDR is less than 200 units, then the light will switch on and there will be a message on the serial monitor. So where is the serial monitor? It's on the top right corner. It's a little bit blur. So here is the serial monitor. This one is the serial monitor. As you can see, it is showing all the values as well as the message turn on the LED and turn off the LED. So there will be a message on the serial monitor that the light has been turned on, or else the serial monitor will show the LED that it has been turned off and there will be no light. Now I will start the code by defining the two constants, that is the LED pin and the LDR pin. The LED pin and the LDR pin for the respective components, and then I will write the serial begin and I will set the baud rate to be 9600. Now after writing the serial begin, we will define the pin mode LED to be the output pin. So this is the pin mode, LED output pin, and the LDR to be the input pin. This is the LDR to be the input pin. Now as we go down in the loop section, we will read the value of the LDR pin using analog read function. So if the status is less than or equal to 200, then we are going to turn on our LED. So as you can see over here, we are reading the value of the LDR pin, and if the status is less than equals to 200, then we are going to turn on the LED pin, that is LED pin high. So after our LED pin has been turned on, it displays the status, or else we will turn off the LED and display the status. So here we are also trying to interface LCD screen with the Arduino. So according to different pins of LCD, we are using different connections from Arduino as well as from breadboard. So in this circuit, as you can see, we are also giving power using the 5-volt signal pin, and we are trying to print the message on or off on the LCD screen. Now I've compiled and I've uploaded this code to the Arduino. From here I can compile and from here I can upload. This is upload, this is verify, that is compile. So I've already uploaded the code in Arduino. So as you can see that as soon as I cover my hand with the LED, so as soon as I cover the LDR with my hand, the signal that is being received by the Arduino goes below 200 and the LED glows like this. You can see the LED glowing, right? So when I block the light from reaching the surface of the LDR, then also the LED glows, and when I simply cover the LDR with my hand, then also. And this is the serial monitor. So when I block the light from the surface of the LED, then its value decreases, that is less than 200, and when again otherwise it's above 200. You can see right now the LED is not glowing and the value is above 200. So as soon as I block the light, you can see the value becomes less than 200. Serial monitor is available at the top right corner of the Arduino software over here. And when we click on it, we can see that the message is being displayed along with the values that we are receiving. So when I cover the LDR with my hand, you can see that the value is less than 200 and the serial monitor is showing that LED has been turned on. So you can also see that the LED has been switched on. So this is how we can operate this project. So you can see I've blocked the light. So in the serial monitor it's showing turn on the LED with the values. But when the light is falling on the LDR, when the LED doesn't glow, the serial monitor is showing turn off the LED. Turn off the LED with the values which are above 200. So this project that we have created is very simple and it is very efficient as well as very useful. So if implemented on a big scale. Such projects, when implemented with light bulbs with an additional power source to power those bulbs, can help us to fabricate automated lighting systems that can be used in different areas of industries, as well as in street lights, where energy consumption is a critical factor. So automated switching on and off of the lights can save a lot of energy, thereby reducing the overall costs. That's all for now. I hope this video has been helpful. Thanks for watching. Yeah. Thank you.